Hello, welcome to Code Design. Today we'll be solving a traditional problem, coding interview problem, which is finding friend circles. And let's see, and this problem is a graph problem. So you can represent the friend circle as a matrix, and eventually matrix representation is one of the graph representation as we know. So let's look at the problem. There are n students in a class. Some of them are friends, while others are not. Friendship is transitive. So if A is a friend of B and B is a friend of C, then A is actually also a friend of C. So what we need to implement? We need to implement a function, friend circles, character array, two-dimensional character array, or if we are doing in Java, since we are doing in Java, we can use list of string also. So what the function will return? The function returns the number of friend circles in the class. So there are n by n matrix of characters y and n. And what these friends ij represent, so row is I and j is column. So say friend 0 0, that means 0 is always friend with 0, right? Like 1 is always friend with 1. Is the same student. 2 is friend with 2 and 3 is friend with 3. So this is always true, but we will ignore this because they are the same number or same student. So students are labeled 0, 1, 2, 3, right? So let's see, let's consider the first one. It says 0 friend with 0, which is natural, is the same person. But here, row 0 and column 1's y, that means 0 is a friend with 1. So we get here one relationship here. 0 is a friend with 1, this direction. It's a bidirectional, and then for this one, we see that 0 is friend with 2, no. 0 is friend with 3, no. For the next row, for student level 1, 1 is friends with 0. So this is the same relationship. It's a bidirectional relationship. And 1 is friend with 1, which is default is the same person. And 1 is friend with 2. So we get 1 is friend with 2. And there is no friendship between 1 3. And for 2 here, 2 is friend with 0, no. 2 is friend is with 1, yes, 1. So it's a bidirectional relationship. And 2 2 is default, 2 3, no. So for the third one, 3 does not have any connection with any of them except 3. So 3 is friend with 3. So what we find here, we find basically true group. This group becomes 0, 1, and 2. So basically 0, 1, 2. This is one group and 3 is a different group. We get two friend circles. So the number of friend circle for this example is 2. So we have the constants here. What are the constants? Um, the time complexity of this program has to be O(n) square, and space complexity O(n). So given these things, and there is a description whatever I just mentioned, right? So it says that if we draw a graph with this thing, there will be a graph 0 to 1, 1 to 2. This is one connection, and then another connection is 3. So we have two friend circles. Number of friend circles in this example is 2. So what are the so this graph problem we can easily solve with a DFS, depth first search, which is the easiest one to implement, and we can also use breadth first search. We can also use union find when we need union find, when there will be constraint of how much. So when n square is not accepted, so we need a better one. Then we can do a little bit optimization with union find. So when we have a strict runtime and the graph is very big, say we are considering with hundreds of thousands of students, then this DFS is not going to work. So it will have runtime runtime out you will get on hackerrank kind of platform. Even on lead code, if the input is very large, it will not work. So, what we do on DFS basically. So, on DFS, we basically visit a node, right? We basically visit a node and then mark the node as visited. So, we say visited, say our node is 0. So, we mark it to true, and then we find all the nodes connected with that node. So all the nodes connected with that 0, and then for all the nodes we called this DFS recursively. So let's go to the implementation part. Let's see how we can implement this. So this is our input, which is a two-dimensional array, or a string, I would say. So we have YYNN for the first one, and is the same example that we had, and we can pass it, and we can see the output. So for this one, this is our main function, friend circles, which takes a list of string. For 0, right? This is for 0, this is for 1, this is for row 2, this is for row 3, and these columns indicating yes or no. If column 0 is connected with column 0, column 1 is connected with column 0, this kind of thing. So what we need, right? In order to find this, we need a function. This is our main function, friend circle. So we need to find the count of groups. So it's there, and we need to call a DFS function. What we need to pass on the DFS function, we need to pass the list of friends, we need to pass the Boolean array visited, and we need to pass a student. So let's implement this one. So for implementation, we can define the Boolean array visited, and let's do one thing before. Okay, new Boolean. Before we do that, we need to pass the count, right? So let's say n equals our friends dot count size. So this is our number of student in the class, and then we can define the Boolean array for these n number of students, and then we go through all the students. We iterate through all the students. I equals 0, I less than n, I plus plus, and what we do for all of them, if not visited, right? If we did not explore that student, then we call DFS for that one. So while we call DFS, we pass friends, we pass number of visited, and we passed our I, which is our student, that the one we want to explore. And then if not visited, if this student is not visited, basically that means we got a new friend circle. So we increment the count and we return the count. So this is our main function. And then let's implement the DFS. How we implement the DFS? We say we visit the student, and we say visited students equals true, and then we get the connected students. So we say connected students for this student. So friends dot get student. So what will happen if student number 0? Then we will have this string connected students. If we are doing it for student number 0, 1, 2, 3, then for 3, these are the connected students with students number 3. So we get the list of connected students, and then what we do, we iterate through. So for DFS, what we do, iterate through all the connected students. So connected students dot length, and then we say j plus plus. So for all the connected students with the students here, we check if um, visit if our array, right? If connected students dot character at this first, what we check, maybe if not visited, if not visited of, if not visited j, if j is not visited, and connected students of character at j equals, it has to be y, and j cannot be student. I means 0 is always friend with 0, 1 is always friend with 0. So we have to ensure that we don't do this case. So these are our condition. Connected students dot character of j, for that student j, it has to be connected. It should not be visited, and student and this j should not be same. We call this DFS recursively. So when you call this recursive call, we pass the friends, and then we pass the visited Boolean array, and we pass the students j. So that's it. It's concise, the DFS. This is the DFS, and then um, this is the count. So let's run this program to see what it generates. So it's calling these friend circles. So calling this one is coming out. Okay, so number of friend circle is 2. So this is a small example. So that's why only we have only two number of friend circles, and let's go to the time and space complexity. So let's go back to our problem. So for time complexity, what we do basically, we see that this is we are doing for number of students. So one loop is for number of students, and another, so inside that loop we have the DFS call. So where the DFS call will go, the DFS call will go up to the depth of students. The depth of the DFS would be, if one single group holds all n students, so the highest depth of the DFS would be n. So our time complexity is n square, and space complexity, what we use, we basically use um, this Boolean array, which is the length of the students n. So space complexity is n. So I hope you like this. So this is also a, Python version of this one. If you are more of a Python programmer, then you can use this one. It's the same. We define the we get the length, we define the initialize the array, visited array with false, and then this is our DFS, and here we are calling the DFS for all the n students. And this is how you can also try this one. So let me know if you like this. So thank you.